Hello and welcome to another episode in our series where we introduce statistics. We are talking about the Chi Squared test for independence today, specifically demonstrating how we can use statistics software SPSS to do a Chi Squared test for independence. Now, to make things a little bit more, I guess, practically relevant, I am referencing this book. It's totally fine if you don't have it. What these authors have done is they did a study involving 1,000 women from a certain community and gathered a whole bunch of information through surveying them. And they've made that available on their website that we can use in SPSS for various examples. They have 3 different files, and we are going to use the B file for today in case you want to follow along. So we have a whole bunch of variables over here. What we are going to do in our example today, we are going to investigate. There are 2 variables. There's one, the BMI categories that break up the different BMI results into 4 categories: normal, overweight, obese, and morbidly obese. And then we're going to compare that with a variable that measures if the woman had any health issues that limited their everyday function. Health condition over here, and that is a yes or a no, basically a variable. So we want to test if the health limit or the health issues that limited the woman's general day-to-day comings and goings, I guess, limited them from working, etc., if that is independent to the BMI categories. So we are going to start by clicking on Analyze. Let me just make sure you can see the menu over here, like so. We're going to click on Analyze, then Descriptive Statistics, cross tabs, and now we need to pull in those variables. And the first one, as I said, is the BMI categories. Now I already have this in here, so let me just remove it to show what you will probably see. We're going to take that first variable, and we're looking for our health limit variable. And we're going to click on the arrow here to put it in the rows box. And then we're going to look for our BMI categories variable, and we're going to input that in the columns box by clicking on the arrow. Then let's click on the cells here on the right. And we want to check that observed is checked and expected. Row and column percentages, though those may be optional depending on the questions you want to answer. We'll click on Continue. Then above that, the statistics. You want to make sure that Chi Square is checked. That is our test that we're going to use. If you wanted things like effect size, you can check that, Phi and Kramer's V, and whatever else you may be interested in. But for our example, we'll just keep it super simple. Click on Continue there, and then click on OK. There's our output. A little small, but I will click on this and select Print Preview. That allows us to zoom in, not out, in. Not that much, a little bit. That's nice. So we can have something to look at. All right, so now we can answer a bunch of questions. We'll run through a few of them, but of course it's not comprehensive in terms of questions you might encounter. So remember what the test for independence is essentially doing. We have women that did not have any health limitations and women that did. So overall here, out of the 969 that responded yes or no, we have 668 with no health conditions and 301 with some health conditions. So now we're asking that, okay, there's a bunch of them in the normal group, overweight group, obese group, and so on. If these two variables are independent, then it shouldn't matter whether you're in the normal group or the overweight group or so on. The frequencies or the count that we expect, the number of people, should be proportional to how much is in that category. So for example, if I have a total of 668 with no health condition and 301 with a health condition, that's almost a 2-to-1 ratio. In the normal BMI group, I expect no and yes to also be roughly in a 2-to-1 ratio. According to 668 out of 969, that proportion, which would be 68.9%, I expect to be in 68.9% of the total normal categorized people of the 312. I expect to be in the no group, and 31.1% of that column total I expect to be in the yes group, and so on. That 2-to-1 roughly, right? Roughly 2-to-1 ratio, I expect to be what the split is in the overweight group, as well as obese, as well as morbidly obese. And then we can compare that to the numbers, the frequencies that we actually see, and there may be a difference that's substantial enough to suggest that no, it does have an effect which group you're in, whether you have no health conditions or whether you do have some health conditions. It's not independent of the BMI category. So that's what we're trying to see. So you see here, for example, if I look at the overweight category that said yes, I expect 84.8, and I got 74. Now, is that reasonably close to allow for some random fluctuations between samples, or is that significantly far away from each other? That's why we have this chi-square test. So let's go through some questions. One question we could ask, how many normal weight women in the normal BMI category were expected to have a health limitation or a health condition if BMI categories and health limitations were independent, were unrelated? So we can see here that our expected count for women in the normal BMI column that should answer yes, we expect, is about 97. And we got an actual count, an observed score, if you will, of 85. There's a difference there. Is it big? It's hard to say, right? That's the whole point of the chi-square test. So we can look at these like, oh yeah, there's a difference there. Look at these two, they're super close together. So it's very much in line with what I observed, with what I expect. So we can ask another question. What percentage of all women had a health condition that limited their ability to work. As we said here, that 31.1% of my observed, surveyed 969 women were in this yes category and answered yes. So what's the null hypothesis that we are using in this chi-squared test? Well, the null hypothesis is that the BMI status or category and having a health limitation, those two are unrelated or independent. That is, that the same percentage of women in each BMI category would have a health limitation versus not, irrespective of which column you're in. It should be the same, roughly 2-to-1 ratio. But then we can look at what the chi-squared statistic actually is. Let me just print preview that and make it a little bit bigger. And we see this first one over here, Pearson chi-squared, is 23.153. Now, if I've done some of these by hand, I would know that that is pretty large and exceeds my usual cutoff scores in the F distribution. So chi-squared, not F, that's another one. In my chi-squared distribution. Usually my cutoffs are far less than that. And that's emphasized here by the, approximated p-value. That is, it stops after 3 decimal places. So all I can really say in this one, it is less than 0.001. So very statistically, highly statistically significant. So we have our chi-square statistic over there. How many degrees of freedom would there be in this? I missed it now. Let's close this. In this test, well, remember the degrees of freedom would be number of columns minus 1, so 4 minus 1, times number of rows minus 1, so 2 minus 1, for a total of 3. 3 degrees of freedom. So let's just make this one a little bit bigger again. Zoom, zoom. So the results, as I said, are statistically significant with a p-value of less than 0.001. Could be much smaller, but that's where, as far as SPSS goes. So that means in fewer than 1 out of 1,000 samples would we expect these kinds of disparities in proportions between observed and expected when it comes to these variables, if the null hypothesis was actually true. So that is our chi-squared test pretty much done, which is a more precise, which gives us a more precise way of analyzing all of these disparities that I've seen. I see some of them. Let's make this bigger again. Not that one. This one. Zoom, zoom. So I have something to look at. We saw from just a casual, informal observation that some of these observed and expected numbers are very close together. But if I look what informally, I'm not showing the chi-squared calculation, but which ones were the major contributors to the chi-square statistic being so large? Well, it seems to definitely be in this last column more than any other, where if I look at the morbidly obese column and the people that said yes to having health conditions, I expect only 28 if these two variables and these two factors were independent, but I got 47 instead. So numbers over here, bigger gaps between observed and expected, and that could be the contributing factor to such a large chi-square statistic, and therefore the contributing evidence that no, these variables are not independent after all, that the BMI category that you're in could be a risk factor for having health conditions. So we can say there is very strong evidence to suggest that the BMI category is not independent from the health conditions that limit working ability. And it may be a risk factor, actually. All right, so that wraps up our quick little demonstration for how we can use SPSS to do an example like the Chi Squared test for independence. Let me know if you have any thoughts, comments, questions, any feedback at all, and we will continue this in the next video. Until then.